All right, let's check out this equal cost and unequal cost load balancing thing. And I did have show IP protocols in the book. I knew I didn't leave that out. Here's some of the output. I've removed the non-EIGRP fields from the info. We saw all of these at the end of the last video. The one I wanted to bring to your attention here, though, is that maximum path 4. That's how many paths EIGRP is going to use for load balancing by default. And the number next to maximum path is the maximum number of paths that it can use. You can see the default is 4. You can change that default with the maximum paths command. Now, let me ease your mind about something here. I get messages on this all the time, and I've seen it online on other sites. It's like, well, I use maximum path and it has 16. Well, I see 24. Well, I see 6. I see different values. Here's the thing. I have seen so many different router models and different iOSs give different ranges for this command. There is no one value for it. I've seen it anywhere from 6 to 32, depending on how high level the router was. Now, don't worry about trying to keep, the model numbers straight. I'm not going to give you any of those because they're not important. It's just a good idea to check this if you're working with the maximum paths command. You can see that 2 routers, in my own rack, the iOS was barely different, and one was 16 and one was 8. So just know how to change it, and that is with the maximum paths command under the router EIGRP config, and also how to verify it with show IP protocols. That's all you need to know. Now, there's a very important value that we talked about at the end of the last video, the variance value. This not only enables unequal cost load balancing, but it determines the degree to which that balancing is going to be enabled. And that's the variance command. All this is a multiplier. That's all it is. The router is going to take the feasible distance and multiply it by whatever we put in for variance. Any feasible successor with a metric less than that new value is going to be entered into the routing table. That's it. And I think we've gotten that detail, really nailed down as to what the variance command is. That's not a complex explanation, but it's going to make a lot more sense when you see it in action. We're going to talk about it on the board here, and then we'll go to the live equipment and take a look at it. Now, look at the path from router 1 to router 2's loopback in the previous tables. The primary route has a metric of 229.7856, and the other route, the feasible successor, had a metric of 232.3456. So by default, we know the secondary route is going to be a feasible successor. We know we find it in the topology table. But the problem is it's only a backup. We're happy that it's a backup that's calculated before we need it, but it's not going to carry packets unless the primary goes down. But by configuring variance 2 in router 1's EIGRP process, the process multiplies the metric of the best route, 229.7856, by whatever we put in for the variance value. That in this case ends up being 45.95.712. Any feasible successor with a metric less than 45.95.712 will now participate in unequal cost load sharing. Now let's go ahead and go to the live equipment, and you'll see how this works. And there's one little classic gotcha here that I want to introduce you to. And I'm going to go ahead and just do a show IP EIGRP top. And I did clear the routing table during a break, so some of the timers in the routing table may look a little odd to you. But here we've got, to router 3's loopback, we have one successor and one feasible successor. Same for the one to router 2. Now, what we're going to do is we want to use both paths to router 2's loopback. And we can do that with the variance command. And it's a good idea to stick with the lowest variance value that you can to get the job done. Because I know what someone's thinking, because I was thinking the same thing once. Let's take a look at the variance command here. The ranges, the acceptable range is 1 through 128. So notice you can't set this one to 0. You can't disable EIGRP equal cost load balancing. The lowest you can set the variance to is 1, and that is equal cost balancing. But we want to do a little unequal cost balancing. Well, the thing is, I know you're going to be tempted one day, just like I was, and just say, hey, I don't need to do any of this math. If you have like 6 different routes, hey, I don't need to figure if I need variance 9 or 10 or whatever. I'm just going to put 128 every single time. And that'll just bring all my available routes in. Boy, that sounds like a good idea, doesn't it? Trust me, it's not. Because what you could have a route that is just really bad. Maybe it's on a dial-up backup link, a 56K link, something like that. And maybe its metric is, 50 times worse than your primary. Well, if you put in variance 51, you could bring that route into EIGRP and do some load balancing over it. But I'm not crazy about doing load balancing when there's that big a disparity in the links. That's where you end up with troubles with reassembly. It's just not a good idea. There's no set in stone value as to how high you should ever go with variance. But I am surprised they let you set it up to 128. So first off, don't be tempted in a production network environment to do that, because you might bring in routes that you don't want to bring in to participate in the load balancing. Another reason to know exactly how to calculate it is I can practically guarantee that when the variance command comes up on your exam in some form, you're going to have to do some figuring. Because I would imagine if I were writing the exam, I would say, what is the lowest variance value you could use to bring in these two routes but not this fourth one, that kind of thing. So having said that, let's go ahead and enter variance 2 to make this happen. And there we go, and we don't really get any commands or any messages, so that could be good. And let's go ahead and take a look at our routing table. Now we've got our routes. You can see what happened here. We've got our routes for 2 and 3. Now we've got 2 routes instead of just the one that we had earlier. That's what the variance command does for us. Notice that it doesn't change the feasible distance one bit. It's not going to change those. What it does is it makes it acceptable to EIGRP to bring that extra route in. Now also note that it did the same thing with 3. And maybe you wanted to do that, maybe you didn't, but the thing is the variance command is all or nothing. You can't say variance to network 2000. You can't do that. Variance is all or nothing. But this is exactly what it does. You're enabling unequal cost load balancing. Don't get in the habit of just setting variance to 128. That's not going to work out well for you on the exam or in a production network. You want to be able to do the math and it's simple math. Just say, how many times do I need to multiply the feasible distance of the successor to make it greater than the feasible distance of the feasible successors? Because that's how you bring them into the table. It's just that simple with the variance command. We are going to stop there for right now and head into another subject when we get back. I believe that'll be auto summarization. I'll see you on the next video.